Hello Internet, this is the High School Scientist, and in this video we learn about momentum and its effects in our day-to-day life. Now when we talk about momentum, there is one thing to keep in mind, that momentum is not something that you can measure over a period of time. This might be confusing, so let's think of what momentum is not rather than what it is. Momentum is not force, but just needs force to occur. Momentum cannot be measured over a period of time, as it can only be measured at an instant of time. But why can't we measure momentum over a period of time? Well, actually you can, but only in a hypothetical situation, or when you have to deal with light, where the velocity remains constant all the time. Let me explain. First off, what is the expression of momentum? It is mass times velocity. But here, if velocity changes, then it's no longer velocity. It becomes acceleration, and mass times acceleration is force and not momentum. Hence, we have shown that momentum is something that is instantaneous, and if it changes over a period of time, then it becomes force. You can even say that force is equal to change in momentum, but since velocity is constant as a requirement, then momentum always stays the same unless there is a change in mass. So if you have to measure the momentum of a moving object, then you take the velocity at that instant and mass of the object. For example, a car is moving at very high velocity, and a train is moving very slowly. Now, how could you tell which of them has more momentum? Well, if you're smart, you would know that an average fully loaded train would weigh around 20 to 40,000 tons, and a car would probably weigh around 1 or maybe even 2 tons. So even if a 40,000 ton train is moving at 10 meters per second, the car would have to move 10 to 15% the speed of light to have equal momentum as the train. So the answer is pretty simple. If you have more mass, you have more momentum. Or if you have a higher velocity, still you gain more momentum. So you just have to remember that momentum is not force, and if you need force, you have to change momentum. Of course, on the topic of momentum, we have to take a look at what is conservation of momentum. Now, this conservation of momentum is universally true, where the momentum of a system always remains the same and never changes. This is where if a particle loses momentum, it doesn't actually lose momentum. In reality, it actually transfers momentum to another particle, and the amount of momentum loss is equal to the amount of momentum gained by all the particles involved in this transaction. Okay, so now that you know what momentum is, you are prepared to answer my question. If an asteroid is moving at a velocity of 10 kilometers per second, and if its momentum is 20 million kilometers per second, what will be its mass? Moving on to the second and final question. What is the momentum of the moon if its velocity is 1000 meters per second and its mass is these many kilograms? You'll find the answers to both questions in the description below. So I guess that's it for this video. If you learned something, then just spread the word, let your friends and classmates know about this channel. This is the High School Scientist signing off.